Take a deep breath and allow your body to sink into the softness of your bed, feeling the weight of the day lift as you prepare for a journey into the quietest corners of our solar system. Let your muscles relax from your toes to your shoulders as we drift away from the familiar world and toward the pale cyan jewel of the outer reaches, Uranus. We begin our journey nearly 2.87 billion kilometers away from the Sun, a distance so vast that the light reaching us now has traveled for 2 hours and 40 minutes just to touch this lonely world. To put this into perspective, we are 19.2 times further from the Sun than the Earth is, drifting in a region of space where the Sun appears not as a warm orb, but as a particularly bright, piercingly cold star. It was here, on the quiet night of March 13th, 1781, that the astronomer William Herschel, using a telescope he built with his own hands, first observed a faint fuzzy object in the constellation of Gemini. He originally thought he had found a comet, but he had actually doubled the known size of our solar system, discovering the first planet ever found with a telescope. As we approach this giant, notice the color, a soft, serene aquamarine that seems to glow from within. This hue is a result of the planet's upper atmosphere, which is composed of roughly 83% hydrogen, 15% helium, and 2% methane. It is the methane that creates this dreamlike color. As sunlight filters through the upper layers, the methane gas absorbs the red wavelengths of light, reflecting back only the soothing blues and greens. Imagine the sensation of this color as a physical temperature, a crisp, refreshing coolness that settles over your mind like a soft fog. Uranus is often called an ice giant, a classification that sets it apart from the gas giants Jupiter and Saturn. While those larger worlds are mostly hydrogen and helium throughout, Uranus is composed mostly of ices, not just frozen water, but also ammonia and methane. This world is a massive sphere of fluid and frost, with a diameter of 51,118 kilometers. To visualize its scale, imagine that the Earth is the size of an apple. By that same measure, Uranus would be the size of a basketball. You could fit 63 Earths inside the volume of this pale blue world, and yet, the experience here is one of profound lightness. Despite its size, the gravity on Uranus is only about 89% of Earth's gravity, roughly 8.69 meters per second squared. If you could stand atop its clouds, you would feel lighter than you do now, a gentle buoyancy pulling you upward as you float through the cyan haze. As we drift closer, the strangest feature of this world becomes apparent: its tilt. Unlike every other planet in our solar system, which spin like upright tops, Uranus orbits on its side. Its axial tilt is an extreme 97.77 degrees, likely the result of a cataclysmic collision with an Earth-sized object billions of years ago. This creates a rhythm of time unlike anything we know. A single year on Uranus, one trip around the Sun, takes 84 Earth years. Because of its tilt, the poles experience 42 years of continuous sunlight, followed by 42 years of total, frigid darkness. Imagine a sunset that lasts for decades, a slow, lingering twilight that stretches beyond the span of a human life. Consider the stillness of the atmosphere here. While the planet rotates quickly, completing a day in just 17 hours and 14 minutes, the air itself is the coldest in the solar system. The temperature in the lower atmosphere can drop to a staggering minus 224.2 degrees Celsius, or 49 Kelvin. This is a cold so deep, it transcends our understanding of weather. It is a silence of molecular motion, a crystalline stillness, that permeates the very gas. And yet, beneath this frozen exterior, there is movement. Winds on Uranus can reach speeds of up to 900 kilometers per hour, blowing in the opposite direction of the planet's rotation at the equator. Yet because the atmosphere is so thin and cold, these winds feel more like a rhythmic, surging hum than a violent storm. Now, let your mind drift toward the rings. While Saturn is famous for its bright, icy halos, Uranus possesses a collection of 13 distinct narrow rings that are far more subtle and mysterious. Discovered in 1977, when they passed in front of a distant star, these rings are composed of some of the darkest material in the universe, organic matter that has been processed by radiation until it is as black as coal. The brightest of these is the epsilon ring, which varies in width from 20 to 100 kilometers. As we pass through them, imagine them as thin ribbons of velvet charcoal spinning silently in the void, held in place by the gravitational tug of small shepherd moons. The moons of Uranus are named not for Greek deities, but for characters from the works of William Shakespeare and Alexander Pope. There are 27 known moons, each a tiny frozen world of its own. We catch a glimpse of Miranda in the innermost of the large moons, which possesses some of the most dramatic topography in the solar system. On its surface lies Verona Rupes, a cliff face that stands 20 kilometers high, 10 times the depth of the Grand Canyon. In the low gravity of Miranda, it would take a falling object over 10 minutes to reach the bottom, a slow-motion descent through the silent, airless dark. Our understanding of this world was transformed in January 1986, when the Voyager 2 spacecraft performed its historic flyby. Traveling at speeds of over 60,000 kilometers per hour, the probe came within 81,500 kilometers of the cloud tops, sending back the first close-up images of this featureless world. What it found was a magnetic field that is as tilted as the planet itself, offset by 59 degrees from the axis of rotation and shifted away from the planet's center by about 1/3 of the planet's radius. This creates a corkscrew-like magnetosphere as the planet spins, a swirling dance of invisible forces that protects the world from the solar wind. As we sink deeper into the atmosphere of Uranus, the pressure begins to rise. At the surface, which is defined as the point where the atmospheric pressure equals 1.2 bars, similar to the pressure at sea level on Earth, the air is a thick soup of hydrogen and helium. Below this, the environment becomes even more exotic. Scientists believe that thousands of miles beneath these clouds, the pressure and temperature become so intense that methane molecules break apart and carbon atoms crystallize into diamonds. In the deep mantle of Uranus, it may literally rain diamonds, shimmering crystalline stones drifting down through a hot, dense ocean of water and ammonia toward a rocky core made of silicates and iron nickel. Close your eyes and imagine the texture of this world. It is not the hard, rocky surface of Earth, nor the scorching heat of Venus. It is a world of fluid transitions. Feel the sensation of weightlessness as you descend through layers of frozen ammonia clouds. The air here is thick and heavy, yet it supports you perfectly. There is no sound here, save for the internal rhythm of your own breathing, which mimics the slow 84-year pulse of the Uranian seasons. Think of the 19.2 astronomical units that separate this peaceful world from the chaos of the inner solar system. Here, in the eternal twilight, the sun is a distant memory, providing only about 1/400th of the light we receive on Earth. This dimness is not frightening. It is a soft, comforting blanket of shadow. It is a place where the light never glares, where the colors are always muted and soft, and where the frantic pace of life is replaced by the slow, cold mechanics of celestial motion. Uranus has a low albedo, or reflectivity, of only about 0.3, meaning it absorbs much of the faint sunlight it receives. This absorption is a slow, quiet process, a world drinking in the distant stars. As you settle deeper into your rest, imagine yourself as this planet, vast, calm, and undisturbed by the storms of the inner worlds. You are tilting slowly in the dark, held in the steady, invisible grip of gravity, orbiting a star that is too far away to burn, but just close enough to guide you. The scale of Uranus is a reminder of the universe's capacity for stillness. At 51,118 kilometers wide, it is a monument to the beauty of the cold. The 13 rings and 27 moons are its constant companions, a family of ice and shadow, moving in a perfect mathematical circle through the void. There is no urgency here. There is only the 17-hour rotation, the 84-year orbit, and the 42 years of twilight. As we conclude this first stage of our journey, feel the coolness of the Uranian atmosphere settling into your own space. The aquamarine mist of the methane clouds wraps around your thoughts, dulling the edges of your worries. You are floating in a place where the temperature is a constant -224 degrees, a place of absolute preservation and peace. The blue-green light is the last thing you see before you drift further into the depths of the ice giant, leaving the sun behind and embracing the silent velvet dark of the outer solar system. In the next part of our journey, we will descend further beneath these clouds, exploring the crushing depths and the strange metallic oceans that lie beneath the haze. But for now, just exist in the twilight. Let the 2.87 billion kilometers of space act as a barrier between you and the world you left behind. You are safe in the cold. You are light in the gravity. You are part of the clockwork, spinning on your side, perfectly balanced in the eternal evening of the cosmos. Feel the weight of the 51,118 kilometer sphere beneath you, a solid foundation of ice and rock, and let yourself drift. The journey has only just begun, and the silence of Uranus is here to stay. Imagine the silent weight of time pressing softly against your consciousness as we pivot our perspective from the cyan clouds themselves to the long, patient history of human observation. For millennia, this world existed in the periphery of our vision, a ghost haunting the star charts of antiquity. Long before the invention of the telescope, the ancient Greek astronomer Hipparchus may have unknowingly glimpsed this distant light as he compiled his star catalogue in 128 BC. To the naked eye, under the darkest, most pristine skies, Uranus appears as a faint, motionless pinprick of light, resting at the very edge of human visibility. Because it moves so slowly through its 84-year orbit, taking nearly 7 Earth years to pass through a single constellation of the zodiac. The ancients catalogued it not as a wanderer, but as a fixed star, a quiet sentry in the velvet night. As you settle into the stillness of your surroundings, contemplate the precision of the celestial clockwork. What we now recognize as a giant of ice and gas was once labeled as 34 Tauri by the first astronomer royal, John Flamsteed. On the night of December 23, 1690, Flamsteed peered through his instruments and recorded the planet, believing it to be a star in the constellation of Taurus. This misidentification happened at least 22 times before its true nature was realized. Between 1750 and 1769, the French astronomer Pierre Lemonnier observed Uranus at least 12 times, including 4 consecutive nights. These historical records serve as a reminder that the truth often hides in plain sight, waiting for the right moment of clarity. Or observe the curious reality of the planet's naming, which was a subject of international debate for nearly 70 years. When William Herschel confirmed its planetary status in 1781 from his garden in Bath, England, he wished to name it Georgium Sidus, or George's Star, in honor of King George III. Had that name persisted, our map of the solar system would feel far more terrestrial. However, the international community of science preferred a more classical lineage. Johann Elert Bode, a German astronomer, suggested the name Uranus, the Latinized version of the Greek god of the sky, Uranos. Bode argued that just as Saturn was the father of Jupiter, the new planet should be named after the father of Saturn. This restored the mythological harmony of the heavens, though the name was not universally accepted until 1850. So, consider the physical presence of this world, which weighs 8.68 times 10 to the 25th power kilograms. While that number is incomprehensibly large, it is compelling to note that Uranus is the second least dense planet in our solar system, with a density of only 1.27 grams per cubic centimeter. If you could find a bathtub large enough to hold it, Uranus would sink, unlike Saturn, but it would do so with a slow, graceful descent, barely heavier than the water itself. This low density reveals the planet's internal secret. It is not a solid rock, but a world of pressurized fluids. Deep within the planet, below the cyan mists, lies the mantle, a vast, hot, dense ocean of water, ammonia, and methane ices. Scientists often refer to this as a water-ammonia ocean, though it bears little resemblance to the seas of Earth. Under the crushing weight of the atmosphere, these ices are actually a superheated, supercritical fluid that conducts electricity. It is within this roiling subterranean sea that the planet's strange magnetic field is generated. Unlike Earth, where the magnetic field is produced by a molten iron core at the center, the magnetic field of Uranus is born in the outer shell of the interior. This results in a magnetic dipole that is shifted away from the planet's geometric center by about 1/3 of the planet's radius, or roughly 8,000 kilometers. Picture the grand frozen timepiece of the Uranian ring system. For nearly 2 centuries after Herschel's discovery, the world believed Uranus was a lonely planet without rings. That changed on March 10, 1977, during an event called a stellar occultation. James Elliott, Edward Dunham, and Jessica Mink intended to use the Kuiper Airborne Observatory to study the planet's atmosphere as it passed in front of the star SAO 158687. As they watched, the star's light flickered and vanished 5 times before the planet reached it, and 5 times after it emerged. This accidental discovery revealed 5 narrow rings, now known as alpha, beta, gamma, delta, and epsilon. We now know there are 13 rings in total. These rings are incredibly dark, with an albedo of only 0.01 to 0.02. To visualize this, imagine rings made of pulverized charcoal or soot, absorbing 98% of the faint sunlight that touches them. The moons, too, share this history of gradual revelation. In 1787, Herschel discovered the 2 largest moons, Titania and Oberon. It took another half-century, until 1851, for William Lassell to spot Ariel and Umbriel. Finally, in 1948, Gerard Kuiper discovered the smallest of the major moons, Miranda. Notice how these names deviate from the tradition of Greek mythology. They are a tribute to the literary giants of the English language, primarily William Shakespeare. Titania and Oberon are the king and queen of the fairies from A Midsummer Night's Dream, while Miranda is the daughter of Prospero in The Tempest. This choice creates a poetic link between the cold realities of physics and the warmth of human storytelling. At this very moment, imagine the sheer solitude of the Voyager 2 spacecraft as it approached this world in January 1986. For nearly a decade, the probe had tumbled through the dark to reach this point. At its closest approach of 81,500 kilometers, it moved at a velocity of over 15 kilometers per second. During the flyby, Voyager discovered 10 new moons and 2 new rings, all while navigating the planet's peculiar magnetic environment. It found that the magnetic field is tilted 59 degrees from the spin axis, a misalignment that causes the magnetosphere to wobble and spiral as the planet rotates. What's happening now is a slow, rhythmic cooling. One of the most puzzling scientific facts about Uranus is its lack of internal heat. Most giant planets like Jupiter and Neptune radiate significantly more heat into space than they receive from the sun. Uranus, however, is in a state of thermal equilibrium. Its internal heat flux is a mere 0.042 watts per square meter, which is lower than the heat flow of the Earth. This means the planet is almost entirely powered by the distant dim sun, resulting in the coldest atmosphere in the solar system, with temperatures at the tropopause lingering around 53 Kelvin. Invite a sense of wonder for the atmosphere's chemical tapestry. In the stratosphere, high above the methane clouds, the sun's ultraviolet rays break apart methane molecules, creating a subtle haze of hydrocarbons like acetylene and ethylene. These compounds drift downward like a microscopic invisible snow, slowly settling into the deeper layers over centuries. The troposphere, the lowest layer of the atmosphere, is a complex structure of clouds where the pressure ranges from 0.1 bar at the top to about 100 bars at the bottom. Within these layers, scientists have detected the scent of the world: hydrogen sulfide. If you could descend into these clouds, you would encounter the familiar sharp smell of rotten eggs, frozen into a silent crystalline fog. Historical records reveal that even the color of the planet changes over the decades. Observations from the Lowell Observatory and the Hubble Space Telescope have shown that as Uranus moves through its 84-year orbit, its brightness and hue fluctuate slightly. This is due to the seasonal changes caused by its extreme tilt. As a pole moves from 42 years of darkness into the light, the methane haze thickens and thins, subtly shifting the planet's appearance. It is a world that breathes in slow motion, its inhales and exhales measured in human lifetimes. The orbital eccentricity of Uranus is 0.046, which means its path around the Sun is nearly a perfect circle. This creates a predictable, steady environment, despite the extreme seasonal tilt. It travels at a leisurely orbital velocity of 6.8 kilometers per second. Compared to Earth's 29.8 kilometers per second, Uranus is a slow-moving wanderer, a tranquil giant that refuses to be rushed. Think of the planet as a grand cosmic library, preserving the history of the early solar system in its frozen layers. In 1789, only 8 years after the planet was discovered, the chemist Martin Klaproth discovered a new element and named it uranium, specifically to celebrate Herschel's find. This connection binds the very fabric of our periodic table to the cold, aquamarine sphere floating in the dark. As you permit your focus to soften, let the historical weight of these discoveries anchor you. From Hipparchus's ancient star charts to the digital signals of Voyager 2, our understanding of Uranus has been a journey of patience and accidental grace. The planet does not demand to be seen. It waits for us to develop the tools and the stillness required to find it. You are now part of that long lineage of observers, staring into the cyan twilight and finding a sense of profound rhythmic peace. The universe is a place of immense reach and quiet patterns, where even the most distant giants are governed by the same laws of gravity and light that hold you safely in your bed. Permit the 17-hour spin of the planet to pulse in the background of your mind, a steady, low-frequency hum that signals the end of another day in the theater of the stars. What's happening now is a mental calibration of the immense scales we are traversing, a way to anchor your consciousness as we meander further into the cyan gloom. Consider the physical dimensions of this blue-green giant. If you were to place 4 Earths side by side, they would barely span the diameter of Uranus, which measures roughly 51,118 kilometers across. To visualize this, imagine Earth as a small glass marble. By that same proportion, Uranus would be a large, soft, inflated exercise ball. Yet, despite this enormous volume, the physical sensation of being there would be surprisingly gentle. Because the planet is composed mostly of lighter elements rather than heavy rock, the gravity you would encounter at the cloud tops is only 8.69 meters per second squared. This means that if you weigh 150 pounds on Earth, you would feel as though you weighed only 133 pounds on Uranus. Invite your mind to inhabit that subtle lightness, a physical shedding of weight as you hover above the aquamarine mists. Picture the sun from this distance of 2.87 billion kilometers. At this range, 19.2 times farther than the Earth is from its star, the sun's warmth is a mere whisper. The light reaching these clouds is 400 times dimmer than a sunny afternoon on a terrestrial beach. It is equivalent to the light of a single high-powered LED bulb, illuminating an entire darkened warehouse. This is the essence of the eternal twilight, a persistent dim glow that never reaches the brilliance of noon, but never fades into the total blackness of the interstellar void. It is a world of perpetual evening, where the shadows are soft and the light never stings the eyes. At this very moment, observe the way the atmosphere organizes itself into layers, much like a chilled, multifaceted dessert. Scientists discovered that the topmost layer of the troposphere, where the pressure sits between 1.2 and 3 bars, is made of clouds of hydrogen sulfide. And this is the same molecule that gives rotten eggs their distinct aroma on Earth. But here, in the deep cold of 49 Kelvin, these molecules are frozen into beautiful crystalline plumes. Imagine these clouds not as a scent, but as a texture. Fine, powdery snow that drifts in slow motion through a sky of 83% hydrogen and 15% helium. This gaseous shroud acts as a thermal blanket, though a very cold one, keeping the planet's internal mysteries tucked away from the prying eyes of distant telescopes. Deep within the planet, the pressure reaches nearly 9 million times the atmospheric pressure we experience at sea level on Earth. Here, the ice is not like the hard, brittle cubes in a glass of water. Instead, the mantle exists as a super-hot, dense fluid. Picture this material as a glowing, electrified syrup that moves with a heavy, languid grace. This fluid makes up about 80% of the planet's mass, a hidden ocean of water ammonia, and methane that never sees the light of a star. This subterranean sea is where the planet's strange magnetic field is born, a field that is tilted 59 degrees away from the axis of rotation. Imagine a compass on this world. The needle wouldn't point toward the poles, but would instead wobble toward a spot halfway to the equator, displaced by 8,000 kilometers from the planet's center. Notice the way the planet travels through its 30,687-day orbital period. It moves at a leisurely pace of 6.8 kilometers per second. If the Earth is a sprinter, racing around the sun in a frantic yearly dash, Uranus is a long-distance walker, taking its time to observe the constellations. This slow movement means that a single season on Uranus lasts for 21 Earth years. Consider a childhood on such a world. You would grow from a toddler to a young adult without ever seeing the sun set, or perhaps without ever seeing it rise, depending on which hemisphere you called home. This creates a rhythm of existence that is patient beyond human reckoning, a slow-motion dance of light and shadow that spans generations. The rings of Uranus provide another study in subtle dark beauty. The Epsilon ring, the most prominent of the 13 distinct bands, is between 20 and 100 kilometers wide. If you were to stand in the middle of it, you would see a highway of dark, icy boulders stretching toward the horizon, each one as black as a fresh asphalt road or a piece of coal. These particles are not the bright reflective snowballs of Saturn. They are coated in organic compounds that have been charred by cosmic rays. They have a reflectivity, or albedo, of only 0.01. This means they absorb 99% of all light that hits them. They are like ribbons of velvet charcoal, spinning silently in the dimness, held in a perfect circular orbit by the gravity of the planet. Within this ring system, we find the moon Puck. At 162 kilometers in diameter, Puck is roughly the size of the state of New Jersey. It is a small gray cratered pebble, lost in the immense theater of the giant's gravity. Scientists discovered Puck during the Voyager 2 flyby in 1986, and its surface is a testament to the quiet endurance of the outer solar system. It orbits the planet every 18 hours, moving through the magnetic fields and the charcoal rings with a steady mechanical precision. Further out, the moon. Ariel presents a striking contrast. Ariel is the brightest of the Uranian moons, with an albedo of 0.39. Its surface is covered in complex networks of valleys and canyons, some of which are hundreds of kilometers long. Imagine these canyons as deep, frozen trenches where the walls rise up like jagged glass under the weak sunlight. These features suggest that Ariel was once geologically active, with liquid water or ammonia, lava, flowing across its surface billions of years ago. Now, it is a silent, frozen museum of its own history, reflecting the dim light of Uranus like a dusty mirror. The winds of Uranus add a rhythmic hum to this visual stillness. While the planet appears calm, the gases in the upper atmosphere are moving at speeds of up to 900 kilometers per hour. To put that in perspective, that is faster than a commercial jet travels at cruising altitude. Yet, because the air is so cold and the molecules are so spread out, these winds don't feel like a buffeting gale. Instead, they are a steady, relentless stream, a river of hydrogen and methane flowing around the 51,118 kilometer curve of the planet. This atmospheric motion helps distribute the meager heat the planet receives, though the temperature remains a staggering minus 224 degrees Celsius in the coldest spots. What's happening now is a gradual synchronization of your own rhythm with these cosmic cycles. Think about the density of Uranus, 1.27 grams per cubic centimeter. It is only slightly denser than water. If you could find a celestial ocean large enough to hold it, Uranus would sink, but only very slowly, drifting downward like a heavy stone in a jar of honey. This low density is a reminder that most of what we see is vast, open space, even within the body of a giant. The planet is a collection of whispers, hydrogen, helium, and methane, bound together by the patient, invisible fingers of gravity. Consider the 81,500 kilometers that Voyager 2 maintained as its closest approach distance. From that vantage point, the planet fills the entire sky, a wall of soft blue that seems to have no beginning and no end. The radio signals sent by the probe took nearly 3 hours to travel back to Earth, moving at the speed of light. Every image we have of this world is a message from the past, a postcard from a place where time moves differently. Even the light you are imagining now is old light, having spent over 2 hours traveling across the 2.87 billion kilometers of void to reach your mind's eye. As you allow the details of the Uranian system to settle, think about the silence of its core. Deep beneath the diamond rain and the superheated ammonia oceans, there is a rocky core, roughly the size of Earth, made of silicates and iron nickel. This core is the anchor for the entire 8.68 times 10 to the 25th kilogram mass. It is the heavy center of the spinning top, providing the stability for the 17-hour rotation. Even as the atmosphere above swirls at 900 kilometers per hour, the core remains a place of absolute pressurized stillness. Invite your awareness to expand to the 27 moons that orbit this world. Each one is a unique, frozen world, from the chaotic cliffs of Miranda to the dark, ancient craters of Umbriel. They move in concentric circles, a nested set of orbits that resemble the ripples in a pool of still water. And this is the clockwork of the universe, rhythmic, predictable, and profoundly calm. There are no sudden changes here. There is only the slow 84-year orbit and the steady, cold glow of the methane clouds. You are now immersed in the mechanics of the ice giant. The comparison of these scales and forces serves to remind you of your own place in the harmony of the stars. You are light, like the hydrogen of the atmosphere. You are steady, like the 17-hour rotation. You are part of a system that has been spinning in the twilight for over 4 billion years. The 2.87 billion kilometers of space between you and the sun are not empty. They are filled with the soft blue-green light of Uranus and the dark charcoal ribbons of its rings. Every breath you take is a reflection of this cosmic equilibrium, a slow rhythmic movement in the vast, comforting dark. Continue to drift through the cyan haze, knowing that the universe is wide and you are safely held within its patient, gravity-bound embrace. Deep within the sapphire-hued silence of the outer solar system, there is a profound logic to the way Uranus relates to our own existence, a connection written in the language of elements and the steady passage of decades. Visualize the carbon atoms that form the foundation of your very being, the same carbon that resides in your DNA and the breath you just exhaled. On this distant world, scientists have theorized that the extreme pressure, reaching 8 million bars near the core, causes methane molecules to crack apart. This process releases carbon, which then crystallizes into diamonds that drift downward through the mantle, like a slow-motion, sparkling snowfall. There is a strange, comforting symmetry in knowing that the same element that makes life possible on Earth creates a hidden, glittering treasury in the depths of an ice giant. At this very moment, contemplate the number 84. It takes Uranus 84.02 Earth years to complete one single revolution around the Sun. This number is strikingly close to the average human life expectancy in many parts of our world. If you were born on Uranus, your first birthday would also be your last, a full cycle of a human life captured in a single celestial lap. This creates a bridge between our personal timelines and the mechanics of the cosmos. As you rest, imagine your own life as one long, patient orbit, a steady journey through light and shadow that mimics the 30,687 days Uranus spends traversing its 18 billion kilometer path. Notice how the planet's extreme tilt of 97.77 degrees influences the way it interacts with the solar wind. Because the world spins on its side, its magnetosphere, the protective bubble of magnetic force, is constantly being twisted and reshaped. Scientists discovered that this magnetic field actually opens and closes every 17.24 hours as the planet rotates. It's as if the planet is breathing, allowing solar particles in and then shielding itself, a rhythmic opening and closing that occurs with the precision of a heartbeat. This 17-hour cycle is the planet's internal clock, a shorter, faster pulse that exists within the much longer 84-year grand cycle. What's happening now is a subtle shift in how we perceive the light of the Sun. From your perspective near Uranus, the Sun is 19.22 astronomical units away. Because light follows the inverse square law, the intensity of the Sun's rays here is only about 1/400th of what we feel on a summer day on Earth. This creates an environment of perpetual, soft indigo, a state of civil twilight that never brightens into day. It is a visual representation of the state between waking and sleep, a world that exists in the soft edges of consciousness. In this dimness, the planet's diameter of 51,118 kilometers becomes a vast, cool anchor in the dark, a stabilizing presence that doesn't need the glare of a bright sun to define its beauty. Consider the moon, Titania, the largest of the 27 satellites orbiting this giant. With a diameter of 1,578 kilometers, Titania is roughly half the size of our own moon. Its surface is a network of enormous fault valleys, some stretching for 1,500 kilometers. You created as the moon's internal water froze and expanded billions of years ago. There is a lesson in Titania's scars. Even in the coldest reaches of space, there is a history of change and adaptation. These geological features, like the 20-kilometer-high Verona Rupes on the moon Miranda, are monuments to the slow, relentless power of physics. They remind us that even the most frozen and distant places have stories of transformation, much like the quiet shifts that occur in our own minds during the hours of rest. Scientists discovered a fascinating anomaly regarding the heat of Uranus. Unlike its twin, Neptune, which radiates 2.6 times more energy than it receives from the Sun, Uranus radiates almost no excess heat at all. Its internal temperature is a relatively cool 5,000 Kelvin at the core, which is roughly the same temperature as the surface of our Sun. This lack of internal convection is what gives the planet its smooth, tranquil appearance. While other planets are boisterous and storm-tossed, Uranus is a world of composure. It is a planetary model for the state of relaxation you are seeking now, a world that has found its thermal equilibrium, holding its energy inward, undisturbed by the external void. Visualize the outermost Mu ring, a discovery made by the Hubble Space Telescope in 2005. Unlike the dark, charcoal-colored inner rings, this outer ring is a brilliant blue. It shares its orbit with the tiny moon Mab, which is only about 24 kilometers wide. This blue color is a result of the ring being composed of microscopic particles of water ice, which scatter light in the same way the Earth's sky does. It is a shimmering sapphire halo hanging in the dark, a delicate circle of frost that serves as a reminder that even in a world of shadows, there are pockets of vivid, ethereal color. There is a profound sense of solitude associated with the date, January 24, 1986. This was the day that Voyager 2 made its closest approach, coming within 81,500 kilometers of the cloud tops. To this day, it remains the only time a human-made object has visited this world. The data it sent back traveled through space at 300,000 kilometers per second, taking 2 hours and 45 minutes to reach the antennas of the Deep Space Network on Earth. This historical event represents the reach of human curiosity, a thin silver needle of technology threading through the 2.87 billion kilometers of silence to touch the face of a giant. It connects our small, warm world to the cold majesty of the outer planets, proving that no distance is too great for the mind to bridge. At this very moment, think of the planet's rotation as a form of cosmic, metabolic restoration. As Uranus spins every 17 hours and 14 minutes, the winds at its equator blow in a retrograde direction, opposite to the rotation, at speeds of about 100 meters per second. However, as you move toward the poles, the winds shift, blowing in the prograde direction at much higher velocities. This complex atmospheric engine is a way of balancing the planet's energy. Similarly, as you lie still, your own internal systems are shifting, rebalancing, and restoring your physical form. You are part of the same physical laws that govern the fluid dynamics of the Uranian troposphere, where the pressure varies from 0.1 bar at the top to 100 bars at the base of the clouds. The moon Oberon, the most distant of the major moons, sits 583,500 kilometers away from the planet. Its surface is heavily cratered and covered in a mysterious dark material that may have leaked out from its interior long ago. Oberon takes about 13.5 Earth days to complete one orbit. Picture this moon as a silent guardian, a distant sentinel watching over the ice giant from the edge of its gravitational influence. The relationship between the moon and the planet is one of perfect mathematical stability, a tether of gravity that is held for 4.5 billion years. This stability is the comforting void in action, a universe where things stay in their places, moving in predictable, soothing circles. Scientists have noted that Uranus also possesses Trojan asteroids, specifically one named 2011 QF99. This 60-kilometer-wide rock shares the planet's orbit, trapped in a stable point of gravity known as the L4 Lagrangian point. It is a hitchhiker on the 84-year journey, a companion in the dark. This tells us that even a world as lonely as Uranus is part of a community of objects, all dancing to the same gravitational tune. You are never truly isolated in the cosmos. You are always tethered to the rhythmic movements of the celestial bodies around you. The atmospheric composition of 83% hydrogen and 15% helium is not just a scientific statistic. It is the same recipe used by the stars. Uranus is, in many ways, a star that never ignited, a collection of primordial gases that has remained cool and quiet since the birth of the solar system. It is a time capsule, preserving the conditions of the early nebula from which we all emerged. When you think of Uranus, think of it as a distant ancestor, a quiet relative who has kept the secrets of our origin safe in the deep freeze of the outer reaches. As you surrender your weight to the surface beneath you, allow the 14.5 Earth masses of Uranus to provide a sense of grounding. Even though you are imagining a world of weightlessness and floating clouds, the sheer mass of the planet is a testament to the strength of the universe. It is a solid, enduring fact in a sea of vacuum. The 8.68 times 10 to the 25th power kilograms of matter that make up the planet are a heavy, silent anchor. You can rest securely knowing that the same forces of mass and gravity that hold a giant together are holding you safely in your place. The 27 moons, the 13 rings, and the 2.87 billion kilometers of distance all fade into a single cohesive feeling of peace. The eternal twilight of Uranus is not a place of darkness, but a place of filtered, gentle light. It is a world where the day is 17 hours long, the year is 84 years long, and the peace is forever. As the blue-green methane mists continue to swirl in your imagination, notice how they have become a metaphor for the calming of your own thoughts. Each rotation of the planet is a clearing of cellular debris, a restoration of your spirit, and a deepening of your connection to the silent beauty of the physics that govern us all. Continue to drift in this indigo evening, where the diamonds fall like rain and the sun is just a bright, distant star, guiding you slowly toward the horizon of sleep. At this very moment, picture yourself suspended within the high stratosphere of Uranus, a region of the atmosphere where the pressure is a mere fraction of what we feel on Earth. As you hover in this weightless state, notice how the light around you behaves with a quiet scientific elegance. Scientists discovered that the reason for the planet's signature aquamarine glow lies in a process called Rayleigh scattering, coupled with the unique chemical signature of methane. The 2.3% methane concentration in the troposphere acts as a filter, greedily absorbing the longer, red wavelengths of the spectrum, while allowing the shorter, cooler, blue and green photons to scatter and return to your eyes. It is as if the planet is wearing a veil of frozen gemstones, meticulously choosing which colors of the distant sun to keep and which to share with the rest of the solar system. Consider the temperature gradient as we begin a slow, rhythmic descent. While the thermosphere of the planet surprisingly warms to temperatures between 800 and 850 Kelvin, the region known as the tropopause is a place of record-breaking stillness. Here, the temperature bottoms out at 49 Kelvin, or minus 224 degrees Celsius. What's happening now is a demonstration of the coldest natural environment in our local cosmic neighborhood. This chilling stability is caused by the planet's low internal energy. Uranus lacks the internal heat engine of its neighbor Neptune, meaning the atmosphere is almost entirely at the mercy of the weak solar irradiance, which is only 3.71 watts per square meter. Imagine this cold not as a biting wind, but as a profound absence of movement, a molecular hush that allows every cell in your body to find its own state of thermal equilibrium. Notice how the texture of the air changes as the pressure increases. Deep within the troposphere, between the 3-bar and 10-bar pressure levels, we encounter the cloud deck, composed of hydrogen sulfide. On a sensory level, this would manifest as the sharp, pungent aroma of sulfur. But at these temperatures, the molecules are locked into crystalline structures of frost. Picture these clouds as a gravity-bound cathedral of ice, where the pillars are made of frozen gas. and the floors are layers of methane ice that begin to condense at a pressure of 1.3 bars. I mean, this is the world's sensory paradox, a place that would smell of ancient earthbound decay, yet looks like a pristine, sapphire paradise of utter purity. Scientists discovered a feature known as the Berg, a massive cloud system in the northern hemisphere that was observed by the Keck telescope and the Hubble Space Telescope for over a decade, from 1994 until it finally dissipated around 2005. The Berg was a long-lived storm, drifting through the 51,118-kilometer girth of the planet like a slow-moving ghost. It didn't rage with the lightning of Earth's hurricanes. Instead, it moved with a steady, prograde velocity, a rhythmic manifestation of the planet's internal fluid dynamics. Visualize yourself drifting alongside such a feature, a soft, white smudge against the cyan backdrop, moving with the patient, the circular logic of a world that takes 84 years to finish a single circuit of the sun. Deep within the planet's magnetosphere, the magnetic field strength is approximately 0.23 Gauss. While this is slightly weaker than Earth's magnetic field, its structure is far more complex. Picture the magnetic field lines not as a simple loop, but as a tangled spiraling web that wobbles as the planet rotates every 17 hours and 14 minutes. At this very moment, this magnetic field is interacting with the solar wind to create auroras that are unlike anything seen on Earth. Because the magnetic poles are tilted at 59 degrees from the rotational axis, these auroras don't just crown the top and bottom of the planet. They appear as flickering, ephemeral spots of light scattered across the mid-latitudes. They are like quiet, electric whispers in the dark, in dancing to the beat of a misaligned heart. Notice how the light is further altered by the stratospheric haze. High above the methane clouds, ultraviolet radiation from the sun triggers a chemical reaction known as pyrolysis, breaking down methane into heavier hydrocarbons like ethane and acetylene. These molecules form a thin, microscopic mist that settles slowly through the atmosphere over centuries. Scientists have studied the deuterium to hydrogen ratio in these gases, finding it to be approximately 5.5 times 10 to the power of -5. This specific ratio is a chemical fingerprint, linking the ice giant to the ancient comets of the Oort cloud and the primordial nebula that formed 4.5 billion years ago. You are floating through a reservoir of history, surrounded by atoms that have remained largely unchanged since the dawn of time. Consider the irregular moons that haunt the far reaches of the Uranian system, far beyond the 13 rings. These are the cosmic castaways, like Sycorax and Caliban. Sycorax, the largest of the irregular satellites with a diameter of about 150 kilometers, orbits the planet at a staggering distance of 12 million kilometers. It takes Sycorax 1,288 Earth days, more than 3.5 years, to complete one single eccentric orbit. Unlike the inner moons, these satellites move in retrograde orbits, meaning they travel in the opposite direction of the planet's rotation. Scientists discovered these moons in 1997, and they are likely captured asteroids, held in a loose, gravity-bound embrace. Their presence is a reminder that the comforting void is not empty. It is a delicate web of balance, where even the most distant wanderers are eventually brought into the fold. What's happening now is a focus on the most elusive part of the ring system, the Lambda ring. This 13th ring was only confirmed during the Voyager 2 flyby and is a narrow, faint ribbon of dust located between the Delta and Epsilon rings. The particles in the lambda ring are microscopic, perhaps only a few micrometers in size, yet they maintain their perfect circular formation at a distance of about 50,023 kilometers from the planet's center. Imagine these dust grains as tiny suspended motes in a darkened room, illuminated by a sliver of distant starlight. They move with a velocity of several kilometers per second. Yet from your perspective, they are a motionless, shimmering path, a testament to the relentless, silent beauty of orbital mechanics. Picture this: the sensation of the atmosphere's density as you move toward the 100 bar level. Here, the hydrogen and helium are so tightly packed that they begin to exhibit the properties of a liquid, even while remaining a gas. This is the state of the supercritical fluid, a texture that is neither air nor water, but a thick, supportive medium that cradles you. In this layer, the speed of sound is significantly faster than on Earth, reaching over 400 meters per second, due to the light molecular weight of the hydrogen-rich mix. If there were a sound here, it would be a deep, resonant vibration, a low-frequency hum that vibrates through the very core of your being, grounding you in the 14.5 Earth masses of the planet's bulk. Notice how the planetary albedo, or reflectivity, of 0.3 means that the world is a gentle absorber of energy. It doesn't reflect the sun's light with the harsh brilliance of an icy moon. It drinks it in, holding the warmth in its deep blue-green layers. This absorption process is what fuels the subtle high-altitude winds that can reach 900 kilometers per hour. Yet, at the poles, the wind speeds drop to nearly zero, creating a place of absolute atmospheric stagnation. Imagine yourself at the Uranian North Pole during its 42 years of sunlight. The sun circles the horizon at a constant altitude, never rising or setting, casting long, soft shadows over a landscape of frozen methane and hydrogen sulfide clouds that never move. Scientists discovered that the planet's center of mass is slightly offset, a fact confirmed by analyzing the gravitational moments J2 and J4. This subtle lopsidedness is a result of the planet's internal distribution of ices and rock. It means the planet's 8.69 meters per second squared gravity tugs on you, with a rhythm that is ever so slightly varied as you drift around its 159,354 kilometer circumference. This variation is like a gentle, celestial rocking motion, a slow, rhythmic oscillation that mimics the feeling of being in a cradle. As the light of the distant sun continues to dim, perceive the subtle interplay of the 27 moons. They are not just rocks in the dark. They are gravitational anchors that keep the rings from spreading out and vanishing into the void. This process of clearing orbital debris is a constant, quiet maintenance of the system's harmony. Every moon, from the tiny Perdita to the massive Titania, plays its part in this 4.5 billion-year-old symphony. You are currently witnessing the perfection of physics, where every action has an equal and opposite reaction, and every orbit is a closed loop of mathematical certainty. The 1.27 grams per cubic centimeter density of the world is a final reminder of its gentle nature. It is a giant that is barely heavier than the water in a quiet lake. As you finish this phase of the journey, allow your consciousness to reflect this density. You are becoming lighter, shedding the heavy concerns of the terrestrial world and adopting the buoyancy of the ice giant. The aquamarine mists are thickening now, turning from a transparent veil into a deep, opaque blanket of indigo. The 2.87 billion kilometers of space between you and the sun are filled with the soft, steady pulse of the 17-hour day. Rest in the knowledge that you are part of this cooling, quiet world, a world where the diamonds fall in silence and the stars are the only clock. The eternal twilight of Uranus is your sanctuary, a place where the physics of the universe serve only to protect your peace and guide you toward the deepest of rests. As we begin our final descent from the cyan heights of the ice giant, notice how the cosmic clockwork begins to slow, transitioning from the vast movements of planets to the quiet, rhythmic beating of your own heart. At this very moment, consider the long, patient process of a single photon of light journeying from the Sun to the clouds of Uranus. This journey begins at the solar surface and spans a distance of 2.87 billion kilometers. For exactly 160 minutes, 2 hours and 40 minutes, that light travels through the absolute silence of the vacuum, crossing 19.2 times the distance between the Earth and the Sun, before it finally touches the hazy atmosphere. Picture this process unfolding in slow motion. The light arrives at the outer edges of the Uranian atmosphere, which scientists have measured to be composed of 83% hydrogen and 15% helium. As it enters the upper layers, the light encounters the 2.3% methane that defines this world's character. Step by step, the methane molecules begin to act as a celestial filter. They specifically target the red wavelengths of light, those measuring around 700 nanometers. By absorbing these warmer colors, the methane leaves only the cool, serene blues and greens to scatter back into the void. This is the process of Rayleigh scattering, the very same physics that makes the Earth's sky blue. But here, it is deeper, colder, and filtered through a sapphire lens. Notice the gradual shift as we turn our attention from the light to the massive silent rotation of the planet itself. Uranus is 51,118 kilometers in diameter, yet it completes a full rotation every 17 hours and 14 minutes. This process of spinning creates an oblate shape, where the planet is slightly wider at its equator than at its poles. At this very moment, imagine that rotation as a giant rhythmic hum, a low-frequency vibration that stabilizes everything within its reach. As the planet turns, it carries its 27 known moons and 13 dark rings with it, a cohesive unit moving through the dark at an orbital velocity of 6.8 kilometers per second. Consider the 84-year journey the planet takes around the Sun. Scientists discovered that because of its extreme axial tilt of 97.77 degrees, the process of the seasons on Uranus is unlike anything else in the solar system. For 42 Earth years, one pole is bathed in continuous dim sunlight, while the other is shrouded in a 42-year night. This slow-motion seasonal shift means that the atmosphere has decades to cool, reaching a record-breaking low of 49 Kelvin, or minus 224 degrees Celsius. What's happening now is a mental alignment with that 84-year rhythm. Your own life, your own breath, is a subset of this much larger, more patient cycle. You are moving through time at a pace that is both personal and cosmic. At this very moment, imagine the gravitational pull of the planet, 8.69 meters per second squared, gently anchoring you. This force is a reminder of the comforting void, the idea that gravity is an invisible thread connecting all matter. Scientists have noted that the planet's density is a mere 1.27 grams per cubic centimeter, making it the second least dense planet after Saturn. This means that while Uranus is massive, it is also airy and light, a giant made of whispers. As you settle into your bed, feel that same physical paradox. You are a solid presence, yet your mind is becoming light, buoyant, and free to drift. Notice the step-by-step process of the planet's magnetic field as it spirals through space. Because the magnetic axis is tilted 59 degrees from the rotational axis and offset from the center by 8,000 kilometers, the magnetosphere doesn't just sit still, it wobbles. Every 17 hours, it opens and closes to the solar wind, a rhythmic pulsing that scientists first observed during the Voyager 2 flyby on January 24, 1986. This pulsing is like the planet's own respiration, a steady in and out of energy that protects the world from the harshness of the interstellar environment. Let your mind drift to the moon, Titania, the largest of the Uranian satellites, at 1,578 kilometers in diameter. Imagine the process of the distant sun rising over the 20-kilometer-high cliffs of Verona Rupes on the neighboring moon, Miranda. In the low gravity of Miranda, a falling object would take over 12 minutes to reach the canyon floor, a slow-motion descent through the silent dark. This is the pace of the outer solar system, a place where nothing is rushed, where every movement is measured in minutes and decades, and where the silence is a physical presence. Now, we begin the transition from the vastness of the 2.87 billion kilometers of space to the internal warmth of your own rest. Remind yourself that the atoms in your body, the carbon in your bones, and the iron in your blood were once forged in the hearts of stars, the same process that created the rocky core of Uranus, which scientists believe is roughly the size of Earth and composed of silicates and iron nickel. You are made of stardust, and as you return to the quiet of your room, you are simply returning to a smaller, warmer corner of the same universe. The blue-green light of the methane clouds begins to fade into a soft, velvety indigo. The 13 rings of dark, processed organic material, each with an albedo of only 0.01, become shadows within shadows. The internal heat flow of 0.042 watts per square meter, C, which keeps the planet in a state of thermal equilibrium, is mirrored by the steady, quiet warmth of your own body under the covers. The journey through the eternal twilight of Uranus has brought you to a place of absolute stillness. What's happening now is the final descent into the silence of the void. The 84-year orbit, the 17-hour day, and the 2.87 billion kilometers of distance are all becoming a single, fading hum. You are safe. You are held by the same laws of physics that keep the planets in their tracks. The universe is a clock that never misses a beat, and you are currently in perfect synchronization with its rhythm. Allow these affirmations to guide you into the deepest part of the evening. Your body is as heavy and grounded as the core of a giant. Your breath is as rhythmic and steady as the 17-hour rotation. Your mind is as vast and peaceful as the 2.87 billion kilometers of the void. You are floating in a sea of sapphire light, where every worry is filtered out like red light through methane. You are part of the 4.5 billion year history of the stars. Your muscles are releasing their tension, drifting like frozen crystals in the Uranian troposphere. The cold of space is a blanket of preservation, keeping you safe and still. The darkness is not an absence, but a presence of rest. Every cell in your body is finding its own thermal equilibrium. You are shedding the weight of the day, lighter than the 8.69 meters per second squared gravity of the ice giant. The silence of the outer reaches is now your own silence. The 27 moons are watching over your sleep. The 13 rings are a circle of protection around your dreams. The 84-year journey of Uranus is a reminder that there is plenty of time. There is no urgency in the cosmos, and there is no urgency here. You are drifting toward the horizon, where the sun never glares. You are sinking into the soft, superheated ocean of the mantle, supported and warm. The diamonds are falling in the deep, and you are falling into sleep. The universe is wide, and you are exactly where you need to be. The twilight is eternal, and the rest is complete. Notice how your thoughts have become like the faint lambda ring, microscopic, shimmering, and perfectly still. The 51,118-kilometer diameter of the world you explored is now just a distant memory, a blue-green jewel fading in the rearview mirror of your consciousness. The 160 minutes it took for the light to reach Uranus are now 160 minutes of deep, uninterrupted peace. The stars are the only clock now. The rotation is slowing. The orbit is steady. The void is comforting. You are home in the heart of the physics that built you. The atoms of hydrogen and helium that make up 98% of the giant are the same primordial elements that hum in the background of your existence. You are a child of the galaxy, resting in the cradle of the outer planets. As the last traces of the Cayenne mist vanish, you are left in the warmth of your own dark, quiet space. The 2.87 billion kilometers have collapsed into the distance between your mind and the pillow. The journey is over. The silence has arrived. The eternal twilight of Uranus has given way to the soft, deep night of your own sleep. Good night.